Hi, grade 7. This is a math video for page 201. Let's take a look at problem 1. Problem 1 says list 4 different ratios that form a proportion with 8/12. Now, I'm not going to do it for 8/12. I'm going to show you how to do it with 5/12. Okay? Basically, what they're asking you to do here is they're asking you to come up with 4 different fractions that are equal to 8/12. I'm going to find 4 different fractions that are equal to 5/12. How am I going to do that? Well, I'm going to write 5/12 4 different times. I'm going to create 4 different proportions. And from that, I'm going to create 4 different fractions that are equal to 5/12. How? Well, I'm going to think about the multiples of 12, the denominator. What's 12 times 1? 12. What's 12 times 2? What's 12 times 3? What's 12 times 4? And what's 12 times 5? So far, so good, right? Now, I just solve and figure out the rest of the fractions. This is times 2, so times 2 is 10. This is times 3, so times 3 is 15. This is times 4, so times 4 is 20. This is times 5, so this times 5 is 25. Guess what? These are 4 different fractions that are equal to 5/12. That's what they want you to do for number 1, except with 8/12. Let's look at number 2. Number 2. Number 2 says, describe a reasonable scale for a drawing of my classroom. Okay, our classroom is basically a square. And it's a square that's 30 feet by 30 feet in size. So, for example, if you drew a scale where 1 inch equals 30 feet, your drawing on your piece of paper would be only 1 inch by 1 inch in size for the size of the classroom. And that's kind of ridiculous, right? Who's going to draw a classroom map that's only 1 inch by 1 inch in size, right? So our scale has to be different than this. How? How different? Well, what if we thought in terms of 1 inch equals, say, for example, 5 feet, right? What does that mean for a 30-foot long classroom? Doesn't that mean we'd need some sort of line that's 6 inches long? Because 1 inch is to 5 feet as 6 inches is to 30. The relationship is multiplying by 5 here. Yeah. Maybe somewhere on the board here I've already done the problem for you if you think through it carefully. Where's the scale for number 2 that's up here on the board? Okay. How about number 3? Express 15 inches to 1 foot in simplest form. 15 inches to 1 foot. I'm not going to do that one, but I'm going to do 30 inches to 1 foot. How would we write that in simplest form? Well, first I'd write 30 inches over the top of 1 foot. And then I'd realize, wait a minute, I don't have the same label here. Let's change the feet into inches. And let's write this as 30 inches over the top of 12 inches. And then let's simplify this. Divide by 2, divide by 2, and there's a simplified form for that. Now, this is not your answer. It's the answer to this problem. You still need to solve that problem. How about number 4? They say express $1,105 for 26 jerseys as a unit rate. Nope, not going to do that. But I will do this one. Express $1,200 for 30 jerseys as a unit rate. As a unit rate. Unit rate means that we have to have a 1 on the bottom of the fraction, right? Unit rate. So I'm going to write this as 1,200 over 30. J for jerseys, $1,200. And let's change this so that it's 1 jersey, so that the whole thing is the unit rate. If I did the math on this with a calculator, yes you may, you'd end up with $40 per 1 jersey. A unit rate of $40 for every 1 jersey. The jerseys are running $40 a jersey. How about number 5? Find the rate of change in new customers per hour between 4 p.m. and 5 p.m. I'm not doing that problem, but I'll do one that's similar to it. I'm going to think about 12 p.m. to 4 p.m. 12 p.m. to 4 p.m. What's going on there? Well, let's write out the ordered pairs for this function table for 12 p.m. and 4 p.m. For 12 p.m., it would be 12 p.m., comma, 30 customers, right? And for 4 p.m., it would be 4 p.m. and 15 customers. So I'm writing out the ordered pairs. Now, I got to use that formula for rate of change, which says second y minus the first y over second x minus the first x. Yes, that's the same formula for slope. Slope and rate of change are the same concept. Okay, so second y, 15. First y, 30. Second x, 4 p.m. First x, 12 p.m. This is minus 15 customers. This may seem like negative 8, but it's not. It's not. How much time goes by between 12 p.m. and 4 p.m.? From 12 to 4 p.m., that's 4 hours that go by there. This makes it look like negative 8 hours, but it's not negative 8. The answer is 4 hours. So now we've got this negative 15 over 4, but we're still not done yet because we're supposed to make this into a unit rate. That means putting a 1 hour on the bottom of the fraction and solving for this. Okay? 15 times 1 divided by 4 should give us that answer. The question is, how much is it? Well, 4 goes into 15 3 times with a remainder of 3. This ends up being 3.75 customers per 1 hour, but it's a negative 3.75 customers per 1 hour because this is a negative 15 customers, right? So we're losing 3.75 customers every 1 hour. We are dropping by a negative 3.75 customers every 1 hour. That's the kind of thing they want you to do for 4 and 5. I'm sorry, 5 and 6 rather. Let's go on to 7, where we're finding the slope of line segment AB. Finding the slope of line segment AB. Oh, there's 2 ways to find slope. Rise over run is one way, and that other formula, second y minus the first y over the second x minus the first x. 2 different ways to find slope. So look at point A. Where is that? That's at negative 3, negative 3. And look at point B. Where is that? That's at positive 4, negative 2. If you can use this formula on these numbers, you should be able to find the slope. Now, hopefully you realize that number 7 has to be a positive number because the line's going uphill as you work from left to right. And hopefully you realize that number 8 is going to be a negative number because you're going downhill as you go from left to right on line CD. So keep that in mind. We're going to stop at this point. Hopefully this helps you.